Hello. So today we will discuss chi-square. Chi-square tests are two types. One is test of independence and second one is chi-square goodness of fit test. After this lecture you will understand what is chi-square distribution, right? And you are able to use this chi-square distribution to find out whether the two variables are independent or not. So if I see what is chi-square distribution, then chi-square distribution is, as you already seen in t-test distribution, z-test distribution, right? These distributions are the shape of the curve where the values of a particular variable lies. Now if you remember about t-distribution, the t-distribution depends upon degree of freedom. Same way chi-square distribution is also depend upon degree of freedom. As you keep increasing the degree of freedom, as you increase the degree of freedom from 1 to 10, you will find that shape of the curve changes as you increase the degree of freedom. If you see the 1 degree of freedom, then shape of the curve is this. If you see 3 degree of freedom, then shape of the curve is this. If you see 10 degree of freedom, the shape of the curve is this. What it shows that if you keep increasing your degree of freedom, the shape of the curve is moving towards the symmetric distribution. Right. Now, one more concept before using it into our solving the problem: critical value. As you have come across this term critical value in t distribution and z distribution, how you used it, that if in the curve, if your calculated value lies less than your critical value, then you accept your null hypothesis. This is the area which we call acceptance region. These are the area which is in our acceptance region, right? If your calculated value is more than your critical value, then your value falls in this area and it is your rejection region. So when you have value in this region, you reject the null hypothesis, right? So same way in chi-square test, we find out critical value and then we calculate our calculated chi-square value and compare with it critical value. If it is less than critical value, we accept the null hypothesis. If it is more than it, we reject the null hypothesis. Right? How we calculate this chi-square critical value? We calculate it from the table. Right? For example, if I want to calculate chi-square value for 10 degree of freedom and 1% level of significance, then the critical value is 23.209. Right? If I calculated it for 5% level of significance with 5 degree of freedom, then the value comes out to be 11.070. If you calculated it for, let us suppose, 11 degree of freedom and at 5% of level of significance, then the value comes out to 19.675. Right? So let's put this concept into a problem. Now there is a problem, but the problem says that, or theory says, the gender of a baby in the womb is related to baby's heart rate. There is a theory and doctors believe that the baby girls tends to have higher heart rates. Now we want to test this theory. Now we have formulated a hypothesis where we say that gender of a baby and heartbeat of the baby are independent. What exactly this means that they are independent? It means that there is no relationship between gender of the baby and the heart rate of the baby. Right? There is no relation. No relation means that whatever number of boys you will take, they are having the same proportion of the heart rate as compared to the girls. Okay? We'll see it with the data. Now let us suppose to prove or disapprove it. These doctors have collected the data from 40 mothers or expected mothers. Now they find out that out of these 40 expected mothers, the heart rate and the gender of baby. Now out of these 40, 18 were girls and 22 were boys. Means they collected the data from 40 mothers and they observed the gender of their baby and the heart rate of the baby. Now the gender of the baby is girl, then heart rate is low, then there are 11 girls in this, 11 babies in this. Then the heart rate is high, there is 7 babies in this. Right? Now this table is called, these values called observed values. Right? Why I called it observed values? Because we have collected this data directly from the mothers and we ask them what is the gender of your child, and then we measure the heart rate of the child and note it down in this case. Now the question is whether the heart rate is having any kind of relation with the gender, and we assume it, and we started with the hypothesis. Assumption of our hypothesis, null hypothesis, is that there is no relationship between the gender of the baby and the heart rate of the baby, and alternatively there is a relationship between the gender of the baby and the heart rate of the baby. Now these are the observed values. Now we need to calculate expected value in this. What is expected value? Expected value says that if total girls child out of 40 is 18, right, then low heart rate girls child should also have in the same proportion. If 18 divided by 40 is the proportion of the girls, then out of total heart rate, low heart rate babies 28, then out of these 28, the girls should have in the same proportion of 80 by 40. So statisticians have devised a formula to calculate the expected value. Expected value of every cell is equal to row total of that cell multiplied with the column total of that cell and divided by the total sample size. That is 18 into 28 divided by 40 is equal to 12.6. And if I see this for 7 for girl, then row total is 18 multiplied with 18 divided by column total is 12, 18 multiplied with 12 divided by 40, then it is 5.4. So now in the table we have observed value and expected value. These are the observed value and expected value. Now how to calculate the chi-square calculated value? Now chi-square calculated value is calculated by observed value minus expected value, this one, observed value minus expected value, square it and divided it with the expected value. Now if I go in the first table, first cell, observed value is 11, this one, minus expected value is 12.6, square it, divided it with expected value 12.6. we add them all these values for each cell and we get the total calculated value of chi-square. Now in this case it comes out to be 1.231. So now we have chi-square calculated value is 1.231. Right? Now we need to compare it with the critical value. So in this case the critical value, we are evaluating our theory or evaluating our hypothesis on at 10% level of significance, means alpha is 10% in our case. So critical value at 10% level of significance, and then second term we need degree of freedom, right? So degree of freedom, we calculate degree of freedom on the basis of the formula r minus 1 into c minus 1. What is exactly r? R is number of rows minus 1 into number of columns minus 1. Right? So we have this, if we go for this degree of freedom, then in this case we have 2 rows, so 2 minus 1 multiply with 2 columns, so 2 minus 1, so 1. So we have a degree of freedom 1. So 1 degree of freedom at 10% level of significance. So now let's go back to the table. This one, 1 degree of freedom, this is 1 degree of freedom, and 10% level of significance, this value. This value 2 point, this is 2.706. So our critical value is 2.706. Now see this. Our critical value is 2.706 at alpha 10%, 0.10, and the calculated value is 1.231. Now this calculated value is less than our tabulated value or critical value 2.706. So we accept the null hypothesis. And null hypothesis says that there is no relationship between heart rate of baby and gender of the baby. Right? So what we will do, we will accept the null hypothesis. Right? And null hypothesis says that there is no relation. Both are independent. Right? Thank you.